The overview is we'll talk a bit about, of course, the codes and standards where the provisions are contained, and which ones we should have in our engineering library. Obviously, this is the starting point for design projects. And then we'll talk about cold form steel framed diaphragms, cold form steel framed shear walls, diagonal strap braced walls, and then a few design examples. There's a lot of great information from various organizations in the cold form steel industry, including the AISI website, steel.org, the Steel Framing Alliance website, steelframing.org, the Cold Form Steel Engineers website at cfsci.org, and then also cfssonline.org. A lot of helpful information, design guides, technical notes for design methods and advice that might not be found in the provisions or commentary that I suggest everybody take a look at. The main document for cold form steel design is AISI S100. This is what's called the specification, and where one would go to design or determine the effective section of a particular cold form steel shape, determine flexural capacity, axial capacity, combined loading capacity, as well as determine connection strength. And then if you have some type of connection or member or something that's not contained within the specification that you'd like to determine a value for, there's Chapter F, which contains provisions of how many tests should be run and a determination of a resistance factor or safety factor to be applied to those test results. The version adopted by the 2009 and 2012 IBC, which most folks are on, I think, through the country. There's a few states that have adopted the 2015, but today we'll primarily focus on the 2012 IBC. Supplement 12 of S100-07. In the 2015, it will be S100-12 that will be adopted. The AISI standards, there's several of them, and these are framing standards, if you will. They're called the S200 suite. General provisions, alphanumeric designation is S200. There's also a floor and roof system standard, a wall stud design standard, header standard, lateral design standard, and so forth. And the 2012 versions are in the 2015 IBC, or referenced in Chapter 35 of the 2015 IBC. The CFSCI Design Manual, AISI D113, is based on the S100-12. The D100-07 is based on the S100-07. And it's very similar to the Steel Construction Manual, where it has tables and graphs and so forth. For instance, if you have a typical cold form steel shape and you're looking for the design strength of that shape, you can go in and the nominal values are shown for particular shapes and unbraced lengths. And you can go in and determine capacity multiplied by a resistance factor to get an LRFD value, or divide by a safety factor to get an ASD value. So very helpful. Kind of speeds design along. Then there's the AISI Design Guide D110-07. And currently the more recent one is being worked on and should be out fairly shortly. And that is a very helpful design guide as well, which offers examples on various conditions in cold form steel construction, such as out-of-plane loading, jam studs, and the like. Very helpful. Also wall stud bracing. And then, of course, cold form steel design, if you really want to get into the whys and hows and so forth in depth, it's a very good text to bring a lot of information to you regarding cold form steel design and construction. And then finally, the Structural Engineers Association of California Structural Seismic Design Manual, the 2012 IBC volumes. There's 5 of them in the set. There is in volume 2, I'd like to point out there is a good example regarding force transfer for light frame systems. It's for a wood light frame condition, but might be something that you could apply, for various cold form steel framing conditions. And this is force transfer. We'll talk about this a little bit later on in the presentation. And then there's a cold form steel design example in volume 2. It's example 3. A very good reference. It talks about continuous tie-down systems in a multi-story building. That might be helpful to you.